Hello, you're watching TelecomTV. I'm Martin Warwick. We're here at Mobile World Congress 2011 in the sunny but somewhat breezy city of Barcelona. And I'm talking with John Dunne, who is the CTO of Intune Networks, based in Dublin, in Ireland. John, you're very welcome.
Thank you very much.
Look out the window over there. We can see Gaudi's Cathedral, which began building in the 1890s and in 2011 is about half built. It's an architecture that was designed in the 1860s and 70s and is still with us. However, the architecture of networks is something that needs to change and be built a bit more rapidly than that, and that's what we're going to be talking about now. Let's begin at the beginning. We are here at the show in Barcelona. It's the biggest mobile show on the planet. There's a hell of a lot being talked about data tsunamis and the amount of pressure that's being put on networks by the amount of data that's being carried across them, even though that's what 3G is supposed to be about. And it seems to me there's an awful lot of talk about apps and monetizing apps and all the rest of it, but the network's well behind the curve on this, isn't it? It's all very well talking about these things. What happens if the network actually can't cope or deliver what you want? Is that what's happening?
Yes, I mean the theme at this year's show is applications. Every stand is you're able to go in and play with new devices and tablet devices. But the problem with these devices is that there's a limit on what type of applications you can do. And that limit is based on the physical device itself. There's no connectivity to the network. So the network architecture hasn't changed for 20 years. And these devices are trying to be overlaid on top of the existing architectures. And that's causing a problem. And you can see that because you can't get the bandwidth you need per application on demand.
So what they're trying to do, is it trying to fit a quart into a pint pot? Are they asking for trouble? What is it?
It's like trying to run cars on top of a railroad track. The cars want to go everywhere, yeah. The tracks are fixed. So they end up with a very overbuilt network and underutilised. And of course this is a very ineffective way to cost out a network.
Now, the service providers are obviously betting the farm and the shirts and everything else on apps and app stores and the fact that they're going to monetize all this and make money from it. They're not going to be able to if the network can't cope with it, are they?
No, it seems that something has to give here. I mean, the last 25 years has been about electrical switching, and electrical switching will only take you so far. One of the problems with electrical switching is that everyone's traffic is mixed inside the same electrical switch. So they're finding it very difficult to divide out the traffic and see who owns what, where did your traffic flow, and did you get what you paid for. And one of the things that Intune Networks is bringing to the marketplace is an optical switch which is distributed. And this technology separates out people's flows in a much smarter way. And we believe we can deliver the quality of service that's missing today.
Well, presumably it's faster, obviously it is if it's optical stuff rather than electromechanical or whatever it might be. How does it work?
Well, it's based on a very special component called a tunable laser. And the tunable laser is capable of switching as fast as packets come into the network. This technology has taken 17 years to mature. So unfortunately no one could have done this before now. But with this technology you can do two functions in the one chip. So the laser can change colours to route your packet to its destination and simultaneously transport that packet by transmitting the light. So when you have two functions in one, you get a simpler network with higher performance. And that's the indication or mark of a true breakthrough in technology.
Now let's relate this back to the apps for a moment.
Okay.
Given what you've just been saying, and you have this new optical switch there, does this mean then that you can, on the fly and on demand, provide bandwidth that people want when they're downloading a movie or doing something that's particularly data heavy, and then reduce it when that is over? Within milliseconds?
Within nanoseconds.
Within nanoseconds, that's fast.
Within nanoseconds.
Right.
So when a demand is placed on the network for an unexpected app no one realised was going to take off, the versatility of these components allow the system architecture to change virtually to respond to the traffic. So it's as if you had many different types of networks built into the single infrastructure. And this ability to virtualize or change the network is critical to responding to the traffic. And only when you can respond in a controlled manner can you deliver a service level agreement based on a particular quality of service.
You said it's taken 17 years for the technology to mature sufficiently to be able to do this. presumably the service providers, the cellular operators, etc., want this. Is it now out there in the network anywhere? Is it about to be deployed? Where are you with it?
So Intune has deployed its first trial network in Ireland. The Irish government supported an initiative called the Exemplar Network, and it's an open environment. So this will allow people to come in, work with the Irish government and set up their own tests and see how this new type of network will work. And this year, following on from the Exemplar Network, we're starting our first office application trials with our initial customers.
So is the first applications then are going to be business oriented?
Absolutely. Amazon, for example, have a particular business model where they rent out servers, and they can do 3 tiers of pricing in the server model. So you can book a server, you can pay for a server to have it on demand, or you can get something called a spot price, where you can pitch in a price, and when a server becomes free, you get that. You can implement a similar model for the network, which is something that people have always dreamed about doing, and monetizing the different aspects of the network traffic and bandwidth. This particular product that we're bringing to market does just that.
So is this your own intellectual property? It's Intune's intellectual property, it's yours, and you're going to sell it to the world?
Yes, our background is working on the deep technology behind the actual system. So we've built up quite a large collection of patents and know-how over the past 11 years. And this puts us in a very good position in terms of pushing a global technology out to the world market.
What about the strategy going forward then? Enterprise to start with, corporation and enterprise, yes. What about all the consumer stuff that's coming on 3G and we're there with LTE and eventually with 4G?
Well, the strategy really has to be quite a slow one. Initially, you have existing architectures, so you have to coexist with the technologies that exist today. And our approach is to improve the services that are in the network today by reducing the cost of delivery. The same technology can be reprogrammed through software to add in these new applications and these new advanced applications. And then coming down the line, you have a very significant change called 4G or LTE. One of the issues with LTE is bringing everything back into a centralized point, for example, to do the switching between base stations, will have a certain delay. So if you have a high-definition video application and you're moving between base stations, the handover and to deliver that quality of service during the handover is very difficult with today's architectures. So this is one of the applications in which our technology fits perfectly for providing the backhaul and the switching between those base stations. And again, this will take a few years to come online, but this infrastructure will make a huge difference when that rollout comes.
So does Intune's technology allow service providers and network operators to maintain most of their legacy equipment and put this on top or alongside and run them in tandem, and then remove part of it when they see how it works, or what?
Well, absolutely. The first thing that this technology does is it slows down the need to grow certain parts of the network. So you immediately get control of your operational costs. And once you have those under control, you can start to invest in these new applications and new platforms and services.
Now, you mentioned cost. How much does it cost?
Well, we're using the same technology that every other vendor is using to deliver the technology. The same hardware chips, the same lasers, the same type of chassis and equipment. So we have similar cost base to all of the existing vendors out there. But we have significant savings in terms of power consumption, space. We're doing 2 functions inside one chip through the power of our software. So we're able to reduce the amount of space in each switching office and the form factor of the chassis. We're also able to significantly reduce the overall power consumption of a network by up to 60%. So taking all this into account, we can get a total cost of ownership reduction of between 50 to 80%, depending on the architecture.
That sounds like a good deal, to say the least of it. Now, what about the return on investment then? I mean, obviously the network operators will do well by being able to offer genuine service level agreements with something like this, where you're not going to argue over bits and pieces, because it'll be fairly evident whether or not there's any latency on a high definition television picture or something like that. How long do you think it will take a network operator to make a decent return on investment from this?
Well, we're going to be demonstrating the first applications with an ecosystem of suppliers in Dublin using the Exemplar network this year. We're going into the infrastructure this year as well as a first office application. And generally what happens, a plan will be developed after that to roll out this technology over a number of years. Meanwhile, the communities of programmers and the other parts of the technology jigsaw that have to come together will be done in parallel. So I would expect these new applications to appear within 2 to 3 years.
This is really interesting stuff, and it makes optical switching really interesting. I mean, it's a complex subject and it's very difficult to get over in an interview like this, but this makes it very straightforward and shows how powerful it is. Of course, you're talking about light speed or just sub-light speed. Looking forward and getting beyond the next 3 years and having these things in place, what could be the next step forward from that?
So we're starting off the technology by pushing it into an area of the network that needs it most, and that's the metro aggregation space. So it's a place in between your devices at the access and your IP platforms at the edge. As this technology reduces in cost because of volume, because of the natural trend of technologies to improve over time, you'll see this technology being pushed further out towards the access. You'll also see this being pushed into data centers. So effectively the network will become part of the data center. People will be able to design distributed data centers, pushing the data centers out closer to the user, giving an even better performance. And that will mark the beginning of cloud computing. Cloud computing whereby when you log on, it will appear as if your computer is sitting next to you. Today the networks can't deliver that.
No, because I've sat through a lot of presentations, I've listened to a lot of stuff, I've listened to some reality, I've listened to some guff, and cloud computing sounds great. All right, we solve the security problems, all the rest of it, but to be able to have something like that as soon as you turn something on or you're permanently connected, as soon as you want to use it, it's there. That you think is actually within our grasp and within reach, what, within the next 5 years?
Oh, before that.
Before that?
Yes.
How soon?
Well, we're currently working on a European project which is investigating how exactly this will work. And we're coming to the end of that project, and the tests show that you need a certain delay, minimum delay, between the server that's serving you and your actual device. If you don't architect the network correctly, you can't control that delay. Now, the product that we're bringing to market controls that delay. So as soon as this product can be deployed, we'll see the first trials of real virtual PC and cloud computing.
I must say it's absolutely fascinating. I like to talk about this kind of stuff because it's away from the marketing hype around 4G, which doesn't exist yet, and all the rest of it. This does. Really good stuff. John Dunne, it's been enjoyable. Thank you very much indeed.